Hello friends, so we have a question on probability density function. We are given an fx which is equals to ax into e raised to the power x between 0 to b, and otherwise this function is equals to 0. A and b are some real numbers. So in the a part we have to find the expression for a in terms of b. So we know for a probability density function px dx, if we integrate it from minus infinity to plus infinity, this must come out to be equals to 1, because probability cannot be greater than 1. So in our case the function is 0, except from 0 to b the integral of fx dx must be equals to 1. So putting the value of fx dx, integrating from 0 to b, this will be ax into e raised to the power x into dx, equating this to 1. X into e raised to the power x. This is a standard form. You must have done it. So we can integrate it using integration by parts. You know the formula for integration by parts is, suppose we have a function u and a function v dash. So the integration by part says this integration will be u first function into integral of second function minus integral of derivative of first function into integral of second function into dx. So applying this formula in our given question, the first function we will take x and the second function will be e raised to the power x, because integrating e raised to the power x is very easy. So the first function into integration of second function ax into e raised to the power x, limits from 0 to b, minus integral of derivative of first function, which is a, into integral of second function into dx, limits from 0 to b, equals to 1. Putting limits in the first term, a into b into e raised to the power b, minus putting x equals to 0, it will vanish. And then finding the integral of the second part, this will be a into e raised to the power x dx, 0 to b equals to 1. So this is ab into e raised to the power b minus a into e raised to the power x, limits from 0 to b equals to 1. So we get ab e raised to the power b minus a e raised to the power b, putting x equals to 0 minus 1 equals to 1. So we get is ab e raised to the power b minus a into e raised to the power b plus a equals to 1. So we can find the value of a in terms of b, taking a common and then bringing the rest of the term to the denominator. We get b into e raised to the power b minus e raised to the power b plus 1. So this is the relation between a and b. Now in the b part, it is given that a is equals to b is equals to 1, and then we have to find the value of median. So we know if m is the median, the integral of the probability density function from 0 to m comes out to be 1 by 2. Now in our case the probability density function is a into x into e raised to the power x, where a is 1. So this is x into e raised to the power x integrating from 0 to 1 m into dx equals to 1 by 2. Now again applying integration by parts, the first function into integral of second function 0 to m minus integral of 0 to m derivative of first function into integral of second function equals to half. So this comes out to be m into e raised to the power m minus e raised to the power x, limits from 0 to m equals to 1 by 2. So this is m into e raised to the power m minus e raised to the power m minus 1 equals to 1 by 2. So this is an equation in m. We can solve this equation using the numerical methods or your calculator to get the value of a as 0.768039, or you can approximate it to 0.768. So this is the value of m. And for more such questions where m is our median. For more such questions, do visit our website www.iitnacademy.com and register for regular updates. Thank you.